recently I was asked some questions by a friend of mine, hi Hassan, about conditional compilation and what happens when Java sees code that can never possibly execute based on the logic of the program. So the first thing I want to do is just show you what happens when Java finds code that can't execute. In this example, we have a print statement at the beginning followed by an unconditional throwing of a runtime exception. The runtime exception I chose rather than a checked exception because I don't want the code to fail for having an unhandled exception. But then you'll notice that the line afterwards, where it says system.out.println never, is considered to be an error. And if we hover over that, the objection given by the IntelliJ IDE is unreachable statement. In other words, the compiler thinks that if you bothered writing this code, you probably intended it to actually be useful. And in this case, it knows that it can never possibly run with the code as it is, and it thinks that's probably a mistake, so it bothers to tell you. Now let's change this up just a little bit. I'm going to make this a while loop. So here we have x is 1, and then while x is 0, we print that message never. And of course, we know as humans that that message will never execute. The compiler, on the other hand, looks at that and says, well, x is a variable. Just because it's 1 right now doesn't mean it will always be that. Notice that its ability to look at code doesn't really extend very far. So it's not looking at that and saying, well, it was immediately set to 1 when it was declared. There's no code between that initial assignment and the point where we test it. It's not going to be accessible in a thread because it's a method local variable. So clearly this will never happen. It's not that smart or that detail oriented. So it's willing to let this code stand. But if we make that a final int, in other words, that is truly a constant, compile time constant, now the compiler knows that this code absolutely can never execute. And in fact, what it objects to is that the test makes the body unreachable. So it doesn't, in this case, complain about the body itself being unreachable by underlining the body, but it does amount to the same thing. The same will happen if we use the literal constant false. However, if we make that an if statement, it's perfectly happy with it. Now things start to get really quite interesting. Clearly this code will never actually print never unless we change that to true. But now let's look at the binary that's generated. We'll go out to the command line for a moment. We'll compile the file locally so we can see exactly what's going on. And then we'll use the decompiler, JavaP, to take a look at the generated binary. Notice we ask it to decompile the class name conditional compilation rather than any particular file. We tell it where to find classes, CP classes, and we also say -c, which tells it to show us the generated code. When we do that, you can see in amongst the otherwise perhaps inscrutable bytecode disassembly that it does have the string start, which it prints. That was the unconditional bit. And then it gets this message, never, and prints it. Because, of course, at this point, remember, we have changed the text, so it's definitely going to print that. It says if true. However, if we change this to if false, now, of course, it prints start and nothing else. But if we come back to the command line and recompile it, and then disassemble it all over again, you'll notice this time the message start is still visible in the source code and the printing of that, but then that function returns immediately. It never actually compiled and generated output for that impossible element. This behavior is not dependent on the use of literals like true and false, but it is dependent on the use of compile time constants like a final int. So if we change this back to the x is 1, if x equals 0, you'll see there's still no code in there. If we take out the final x is 1, and just make it a regular variable, this time when we compile it, we see that the message never is present, even though it will never actually be executed until or unless we change the code. So what the compiler cares about is conditionals where we have a compile time constant value and that it knows that that value will never pass the test in question. It's important to realize this works with if. It works with conditionals in general, although there is a caveat about the generated code question here. But it does not work with loops. So you saw that when we had the unreachable loop body, that was a problem. And that's generally a problem. This behavior is a special case for conditional statements. If I replace that code with a switch statement, you can see here we have this final int langnum equals 1. And it is a final. So the only thing that's ever going to happen is that we're going to set message equal to English and then print it. If we look at the generated code, however, you'll see that all the messages are still included. So with the switch, the system is not removing elements of generated binary. However, it does still perform the behavior where it doesn't care if something can never happen. Let's change langnum to 5, and then instead of creating a message of unknown, we'll throw a runtime exception. And you'll notice then it's basically impossible for that last message ever to get printed. We run it, it stops before it gets there. However, the code is still compiled and it still contains all of its pieces. So conditional statements, including switches, will allow you to write code that includes what appears to be unreachable code, and yet not complain about it in the source. The idea is that the compiler thinks, oh, well, you might be doing something special that you're going to change later. However, the switch one still embeds the code. Might be interesting to see if we can perform this kind of situation with a multi-way condition and actually throw the code out. It's probably not a surprise. We can do this successfully if we use multiple if-elses. We put this code in instead, where we have the final int langnum. We declare our message, and then conditionally, based on a series of chained if-elses, we assign one of those. As is, it prints English because the langnum was 1. If we compile it again and disassemble it, you'll notice that English is the only language in there. I think that was probably expected, yes? And just to be completely sure, if we take out the final, we now see that all the other messages are in fact in place. There's one more twist to this, which is that if we use the query colon, the so-called conditional operator, and sometimes you'll hear it referred to as the ternary operator because it takes 3 operands, this one also, langnum is 1, it prints English. If we look at this in a disassembled form, you'll see this actually also only generated the string English in the output binary. Something else to notice about this, and this might actually be a reason for you to want to do this in itself, is that the binary file is actually smaller. It literally does not contain this code. In this form, the size of this binary is 486 bytes. If we remove the final from here, now it's 631 with all those extra messages in. Obviously, this is a very small file, most of which is entirely conditional, so you wouldn't normally get that proportion of benefit. So one of the questions I've hinted at is, why would you be doing this kind of thing? Well, conditional compilation, as we've seen, if it actually is conditional compilation, allows you to remove chunks of code that shouldn't be in a particular delivery. But you don't have to remove them from the source. You can turn them on and off by changing perhaps a simple Boolean flag. Now that can be useful, for example, if you want to have debugging messages that don't show up in general, so your delivered product that you send to a customer doesn't contain the tests, doesn't contain the output for those messages, but you can easily turn those extra messages on when you run the program in development. Of course, this used to be a very common practice 30, 40 years ago. Today, we have logging levels and we can turn that kind of thing on and off dynamically. But sometimes you simply don't want those messages ever to be seen by the end customer. They might give away things that you don't want them to know about your code. You may simply want to keep your code smaller. And it doesn't have to be just debugging messages, things that relate to a particular target platform. If you're selling something and you want a feature to require the customer to pay extra for, you may not want them to have that binary, so there's no possibility of them turning that feature on without having paid for it. There's one final piece, and this actually relates directly to the question I was originally asked. If we change this up again, we'll go back to the final int x is 1 and then if x is 0. Clearly this is never going to happen. But you'll notice if we throw a checked exception in the middle of this, we still get the error that we have an unhandled exception. And you might think, well, if that code's never going to execute, why would you bother to check it? Well, the point, of course, is it's extremely easy to turn that code on again. And if it didn't generate the error when it was clearly wrong until you enabled the code, that just means you don't find out until later. And it's always better to find out about any error, even one that might be suppressed in the current flow of execution, as soon as you possibly can. So where you have this kind of conditional compilation, the error checking is not disabled. And in this case, we can't throw that exception unless we declare or handle it somehow. That makes the error go away.